So thank you all for being here. Good to be in the city I live in, which is the best city in the world, basically. I'm going to do a talk for you that is actually quite new. We had a problem with my laptop, and usually I see what my next slide is. Unfortunately, on this monitor, I cannot. So we're using a laptop in the back. That means I have no idea where this talk is going to, which is pretty much an analogy for my career. So please indulge me. This is a talk about my personal journey in writing code. And I thought, well, you guys come to conferences, guys and girls and everything in between, but you come to conferences, you see everything, you know everything already. So what can I add to that? And I was like, well, maybe the stuff that I learned over the 44 years that I've been writing code, I figured it out last week, actually, and maybe you can take some away of that. Maybe not. I'm pretty curious about what you find out after this talk. So again, as I can stress, this is my personal journey into writing code, right? And I can show you actually that it's a long time ago that I started writing code. So basically what I do, I like to do, well, there's much more that I like, but these are two things that I really, really, really enjoy. That is traveling, which is not much here because I came on my bicycle and it's only 5 kilometers from my home, but okay. And I try to write beautiful code. The problem with writing beautiful code is that beautiful code, what I find beautiful, does not necessarily have to be the code that you find beautiful, right? It is very much in the eye of the beholder. So bear with me, I'm going to show you the code that I like, but not necessarily it's code you like. So I figured out, I had this book called The Lonely Planet Travelist Guide, whatever it's called, and I found this really peculiar word called travelist. And I tried to look it up, because I travel a lot, right? And I tried to look it up, and there was a definition for it. So it actually came from a website called the Travelist something, Travelist Club, whatever that may be. And they find this definition of people who like to travel. And the definition is a bit like this. It's those who wander to fully experience a new locale, the culture, the people, the approaches to the everyday common tasks we'll endure, to learn, to be inspired, to deepen the soul, enlighten the spirit, and refreshen the mind. Now, isn't that cool? That is basically, apparently, what I like to do as a traveler. Now, the question is, does this also relate to how I deal with code? And the answer is yes, actually. And it's been a long, long journey since I got to this stage. And I actually, recently, when I was digging through the archives in my mother's house, I actually found this manual. And this is old, people. This is the manual of my dad's programmable pocket calculator. And this is really cool, because this is actually where I wrote my first lines of code. And if you look at it, it says, well, effortless programming. Can you imagine effortless? We did that back then, right? We had effortless programming. And then it has a manual which really high detailed of the stack and the memory and stuff and how to deal with that and how to work on that. And I was like, wow, this is extremely old. And my dad, who always archives everything, he actually put the date in the manual that he got his personal pocket calculator. So it was the 24th of September, 1977. That is basically where this journey began, right? In 1977. I can imagine that a lot of people here weren't even born back then. And I was like 10, 11 years old trying to figure this stuff out. It was really new. I had no idea what I was going to. So that's basically, as I'm saying this, over the 40 years of doing this stuff, I became sort of a codist, which is an analogy for being a travelist. And it basically says, those who code to fully experience a new locale, an LNL in my case, the culture, the people, the approaches to the everyday common tasks we all endure, to learn to be inspired, to deepen the soul, enlighten the spirit, and refreshen the mind. Now, that is why I write code, basically. So that's the introduction, right? And the thing is, the best thing I learned over time is that you can never stop learning. And that's not about learning a new language, maybe it is, but learning a new framework or figuring out how React 18 works instead of React 17. It's about continuous improving what you do. And improving for you can be an entirely different direction than for me, right? But I'll show you my direction. Now, a little bit about learning is that it comes and, well, let's say levels, right? First, you learn from somebody who's already done it, and then you sort of figure out that there's different ways of doing it. And in the end, you transcend. That's pretty much Zen-like, right? So we're going to talk about Zen too. So what is Zen? Now, I found this on the internet, right? Basically says, Zen is a state of calm attentiveness in which one's actions are guided by intuition. To me, that's an important point. If I write code, and people ask me, why do you write it in this way? And I'm like, well, I've picked up a lot of stuff in the last 40 years, right? And it's just the way I write code. And it changes all the time, right? The way I write code now is very different from how I wrote code 3 months ago. That's only 3 months ago, right? And it says, well, it's basically, look at the Zen of gardening. You become one with the plants, lost in the rhythm of the tasks at hand. Now, isn't that beautiful? Again, if you would translate that into code, it would say, you become one with the code. That would be cool, right? And I tend to have these sort of, when you get into flow, right? I was actually writing code last night, and then all of a sudden I looked up from my monitor. It was 3 in the morning. You know that feeling? And you have no idea where the time went. Your code didn't get any better. My test was still failing, but I was away for like 5 hours. And that state is just, wow, it's a beautiful place to be, right? So the question is, how does learning actually work? And I know Roy is in the audience. Roy, we share this story from this really great book from Gerald Weinberg. And it's about learning. And Gerald Weinberg was trying to learn how to play pinball on the local pinball machine in his local cafe. And he was like, well, it's sort of, you get better at it over time, right? And then he started noting down all of the scores that he had on the machine that he was playing it on. And he figured out it was a graph like this. So apparently, there's points in time where you get all of a sudden a lot better. And that, you know that feeling, right? And that actually happens. And then he tried to figure out what happened actually. Why do I cross this boundary and go and get a lot better all of a sudden? And he figured out, when he actually plotted out all the scores, that it wasn't all that sudden. The thing was, every now and then, he got a new idea. Let's call it an epiphany, right? Something you think, what if I try out this? Does it work? And the story goes that he was trying out multi-ball. Some of these pinball machines, I love pinball, by the way, they have multi-ball, right? Eventually, there's a lot of balls in play, and what usually happens, if you try to keep all of them in focus, you lose all of them. And all of a sudden, they're all gone. And he figured out, what if I focus on just one ball and keep that one ball in mind, and the other ones, whatever they do, they just do what they do, right? And he figured it out, and he tried it out. And at first, his scores went worse, because you're trying out something new that you have no idea whether this will succeed. This is called an experiment. But eventually, it works, and you get better at it. And with those kinds of epiphanies, your scores all of a sudden go up. So the graph is actually a bit like this. You get this idea, you go try it out, and when it doesn't work, well, you abandon it, but when it succeeds, you get a lot better all of a sudden. And I was remembering the story, and I was trying to figure out, so what happened to me in those 44 years? Where did I have these epiphanies? You probably were like, oh yes, that is with reading the design patterns book. It was actually, by the way. Or reading domain-driven design. Yes, it was again. Or seeing somebody's talks. And I'm like, oh yes, I have these ideas. But there are actually a number of really smaller events that change the way I write code tremendously. And it's what Gerald Weinberg says, right? We must learn from any place we can, any way we can, and probably at any time we can. So that is the thing to software development, right? Now, the nice thing is, it's not just about learning. Learning would mean we stack knowledge on top of it, and we get better all the time. But what I've figured out over time is there's a lot of unlearning to do. And I see a lot of people in the industry. I work with a lot of programmers, and I see people that are doing this. They're stacking stuff on top of it, but they're never throwing anything out, which means, well, at some point in time, your head becomes full, basically, right? So it's also about unlearning. And then I found this really nice post on Twitter that says, I actually really, really like this. It basically says, well, you start up with nothing, and then you figure out, oh, I'm just going to do OO. I'm going to do OO everywhere, right? And it works. And it's great, and my code looks nice, and then comes DDD, and you do some design patterns, and eventually you get into abstractions and interfaces and stuff that you're going to add later, making it more generic than it needs to be. You're all here, right? And so am I, by the way. And then eventually, over time, what I realized is that this graph is actually true. Because after programming for 44 years, my code doesn't look like that anymore. I throw away these abstractions and the interfaces as much as I can. I remove dependency injection from my code, because I actually really didn't need it. And yes, it's useful in a lot of places, but I threw everything out. And I went into very different ways of programming. But it took like 40 years of getting here, right? Now, that doesn't mean you're going to end in the same place as I am. It does mean that you learn over time, you get better. My voice isn't really great today, actually. So I'm going to have a sip of water. So what I actually figured out is that I am always on a quest. That, of course, always reminds me of Monty Python, where they ask, "What is your quest?" I always have to do that, by the way. So I'm on a quest for very simple code. Yes, and then I have to answer the question, what's the airspeed velocity of unload and swallow, right? So, but anyway, so that is what I've always been doing. And the thing is, I'm never there, right? It can always get better. If I look at the code that I wrote last night, I'm more happy with it than the code I wrote last week, actually. Really true, by the way. I could actually show that, by the way. So the question is, how does this help you? Well, it doesn't basically, but it helped me. So, an introduction. This is me. I am Sander. I'm what I call an independent dad. I used to be an independent consultant, but my kids take way more time than my work. So I became an independent dad. I have 3 kids, and I speak a bit, I travel a bit, I write a bit. And I'm currently the CTO for an e-commerce company called iBoot, which is based on the other side of the city. So I can bicycle my way to work, which is really good, except that bicycling in Amsterdam is extremely dangerous. But yeah, well, it's living on the edge, right, basically. So if you want to connect, my LinkedIn is also in there, my email, my Twitter, etc., etc. So to prove to you that I'm a programmer, this is my actual name, right? That means I'm actually double object-oriented. Who can say that, right? This is really cool. To make it even worse, I live in the city, in the Javastraat. It's actually true. Cool, right? I also do some open source. I write some open source frameworks. It's called Easy, because, well, you make programming easy, right? Which is a nice repository to look into. It's probably complicated if you see it for the first time. I have no idea, basically. But let's see where we are. So this is a chronological travel journey, right? So it started with me entering a consultancy in 1994, I think. And I had this mentor in this company, and he always said, well, a program is a bit like this. It's like the wall in the desert. And I never forgot this, actually. So this is one of these epiphanies I had. He said, well, imagine you're walking in the desert. And it's in thick fog, so you don't see anything, right? You cannot see 30 centimeters before you. And there might be a brick wall. There likely is, but you don't know. You also don't know where it is, right? So you might run into it, you might not. And you're always a little precautious to maybe bumping into the wall, but it might not be there. That is, to me, what programming is, right? You never know exactly where you are or where you're going to end up. That means that all these managers that try to plan everything, and this is an actual sheet from a manager from a company I used to work for. It's really true. And he did the productivity of every individual developer, and he was, oh, your productivity is a little bit better than yours because you spent so much time, blah, 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 blah. Doesn't really work, right? Stop doing this. It doesn't work. Because basically, as the great programmer Donald Rumsfeld says, well, the known knowns, right? We know that stuff, and there's also the known unknowns. That's stuff we know we don't know, but it gets worse. And there's the unknowns unknowns, and this is where we run into in this industry, because this industry is developing so extremely fast that it's impossible to know everything. None of us do, actually. If you're a master in your own domain, well, there's more domains. That's basically it, right? You cannot know everything anymore. And I have some illustrations for that. So he says, these are the ones we don't know. And these are the ones, he says, well, if you look throughout the history, it's the latter category that tends to be the difficult ones. And that's an underestimation, right? That's ironically. So this is the problem, right? We run into stuff we really don't know. So that means all these managers that you can talk to and say, yes, I get all what you're saying, but when is it going to be finished? For the most of the stuff we do, especially if you're on the innovative side of this industry, this doesn't really work. I think we should all stop talking about productivity here. Productivity is about how many cars did the factory produce this year? What is the volume of my vacuum thing, my hoovering thing that can, well, clean my room? Software doesn't work like that. You cannot say, oh, we've built 2 software, like we've built 2 cars and we configured it. It works maybe if you install SAP, I don't know, or some other package solution where it doesn't really matter, or if you do no code or low code or whatever these things are these days. But for us as a regular programmer, it doesn't work that way. We cannot say, we do 2 software this week. It's my manager, the CEO of the company, he says, how many points did you guys do this quarter? I'm like, 42. He writes that down, and then the next quarter he says, how many points did you do this quarter? I said, 42. He said, wow, that's just about as good as the last time. I'm like, okay. He believes that, actually. So here's the problem. Code is not about typing stuff. It's about the process of writing code. It's the process that takes place in your head. It has to fit in your head, right? So you have to be in a state that your mind can do the processing. And I'm actually, all the time, every day, I have code sort of spinning in the back of my head. Do you have that too? It's annoying, right? It never goes away. Whether I'm on stage, it's actually running here now, on this side today, and or whether I'm doing something else, whether I'm in a meeting usually, or watching TV, riding my bicycle, there's always some code processing in there. And it's annoying, right? And I learned that actually from another epiphany that I got from this guy. So this is at the GOTO conference in Aarhus in 2003. And this is Ken Beck. And Ken Beck said, and GOTO was basically the predecessor of GOTO, right? So, and Ken Beck said, well, I'm not going to refactor the code just yet. Okay? And then he said, because the code doesn't know yet where it wants to go. It took me years to understand this stuff. What is he talking about? I was pretty young, right, 2003. And I was like, I have no idea what this is. And it got to me much later, right? It got to me like, yes, this is the point. It's my head puzzling stuff. And it doesn't really help if I'm on the keyboard or not. If I'm on the keyboard, I'll probably try out 20 different things that all don't work. I can only type it in when my head has figured it out, right? So that means your head has to have the room to do this. Now, that's the problem. And that also means that programming doesn't really work well on time boxes, right? All these sprints that you haven't made, I had a company that called it red sprints, right? Oh, we still haven't finished it. Why didn't you finish the work in this sprint? Well, because of the unknown unknowns, because it lives in my head, and my head is full with other stuff. So I'm sorry, it's not finished yet. It also doesn't work really well from 9 to 5, because my head doesn't work exactly from 9 to 5. It doesn't start at 9, and it doesn't stop at 5. And my voice is getting worse and worse. What's this? I never have this. Anyway. So you have to figure out, as a manager, basically, how a programmer's mind really works. And it's a bit like this, right? I mean, and they think it works from 9 to 12, and then from 1 to 5, and then people go home, and it doesn't work like this, right? I get my thoughts in the shower, or at night when I'm watching television, or even worse, when I'm almost asleep. That's the worst part, right? Because you can't sleep until you figured it out in your head. And this is how our minds work. They don't work from 9 to 5. So what I did with my team is I said to them, guys, I really don't mind. You don't have to work 9 to 5 here, but you have to do the work. That's it, right? You have to do your other best and ask for help whenever you need it. But it doesn't have to be 9 to 5. We can work other times in other places. Right? We don't have to be always in the office, so this is the problem. So what happens? Oh, by the way, did I mention that programming is addictive? You probably don't have that, right? Well, that's probably why you're here, right? So this is the thing. It never leaves my mind. I can actually sit at my keyboard writing code or writing very little code. I could end up with like 2 lines of cool code, but it could take forever, right? And I don't mind. I had my previous girlfriend, or actually the mother of my kids. She never understood this. Like she said, "Why are you working again?" While I'm on the keyboard at night, I said, "I'm not working. I'm writing code." "Yeah, but it's your work, right?" "Yeah, well, sort of." And then when I got a new girlfriend, when I got into a new relationship, I told her, I said, "Well, it could be that I'm on the couch with my laptop, and you're talking to me. I don't hear you." You've been there, right? And then she said, "Okay." And I said, well, it could be that I'm still on the couch at 3 at night, and that you're running, where is he? And, well, I could be still on the couch writing code. I'm not watching porn or something, I'm just writing code. And she said, okay. And I got into a much better situation, right? My current girlfriend is actually trying to learn how to write code, which is an even better situation. So, anyway, this is another thing I learned. I actually learned this from Alistair Coburn, who was in my car. We came from a dinner, and he said, well, here's the thing you have to remember. You have to always travel light. Travel with just sort of maximize the stuff that you don't need, the things you don't bring along, and the work that you don't do. And that was good advice. Because as developers, and you all know this, right, we are drawn towards complexity, right? We love complexity, because that's where the hard stuff gets, right? That is where we really need our brain power. And the problem is, complexity isn't really a smart thing to have, basically. You can much better get rid of it. So Neil Ford says, developers are drawn to complexity like moths are to a flame, and often with the same result. Right? This is what kills us, complexity. So you have to stay away. Gregor Ho puts it even better. He says, excessive complexity is nature's punishment for organizations that are unable to make decisions. So take this home to the organization that you work for, explain that to your manager. So this is worse too, right? And then here's what we do. So this is a picture of every developer ever. And we say, well, we might need this in the future. Eventually, we will need this stuff, right? So you know what? I'll make it a little bit more generic now so we can reapply this later. We'll write it for reuse. I hate reuse, by the way. And what if we replace this database by another at some point in time? So we really need to write this driver independently of all the other stuff. Whoever replaces their database. This is an argument I've heard for like 40 years. I've never done this, actually, in real life. Why do we do this, right? And it's all these words that gets us into trouble, right? These are red flags, like might and in the future and eventually and later and what if. Don't do this, right? And here's the thing that I try to teach to the teams I work with. You have to get rid of premature optimization. We all do this, right? And it creates complexity where you don't need it yet, right? Well, basically, it creates unnecessary complexity. Right? So try to stay away from this. And to make it worse, there's also Hofstadter's law, which says it always takes longer than you expect, even when you take into account Hofstadter's law. That doesn't make it any better, right? And this is very true for everything I do. So here's the deal. I had a serious burnout in 2009, 2010. It took me about a year to get back. And I really needed to focus and to stay away from the stuff that I really don't find important anymore. Right? So I made a list of the things that I found important. My relationship, my kids, taking care of my parents, writing code, traveling, and doing some indoor soccer. And having some friends, stuff like that. But all of the rest, I could get away with. So I said to my current manager when he tried to hire me, I said, I'm happy to work for your company as long as I can write code and as long as I don't have to be in meetings. I'm probably the only manager, I'm a manager now, CTO, right? So I still write code, but I'm probably the only manager who never goes into meetings. I just avoid them, right? I don't like them, actually. So I stay away from the stuff that I don't find important. And the point is, you can only spend your time once. That goes for everything in your life. So for everything you do, you have to figure out whether it's worthwhile. Do you actually want to spend energy on this? So here's the thing that I give to my teams. Well, this is an interesting thing, right? Like a lot of people are solving scalability problems. Most of these people don't have scalability problems, right? So I worked for an insurance company, and we were writing our first microservice in early 2015, I guess. And we tried it out, and it ran on a single instance of a JBus container, and we figured it out, and we could point it, or we could send requests to it 68,000 times per minute. And that was the point in time that we realized we don't have scalability issues here. This is fast enough, right? It doesn't have to be better than this. So this is the point. Solve only the ones that you need to solve. So what I bring to my teams is always this. And they're coming back at me this all the time, right? I taught them to ask these questions all the time to everybody and everyone, even in their own relationships, I guess. And the question is, do we really need this now? Or, to put it more strict, do we really need this now? And in most cases where you can answer, well, we might need this later, don't do it, right? Don't go in that trap to say, okay, yes, we're going to build this already and add a lot of complexity that we don't really need yet. You should add the complexity later, when you actually need it, which could be years in time, or it could never happen. And in that case, you will spend all your time on stuff that you don't need. So I figured out that I needed to go towards making stuff simpler instead of making stuff complex. But making stuff simpler is very, very hard. It's much harder than making stuff more complex, actually. So we needed to stay away from this. And here's a simple realization, right? Code is not a product. Code is cost. Every line of code that you write, it costs your time, it costs other people's time to maintain it or to test it or whatever you do with it. It costs money to run it on somebody's infrastructure. So you have to realize that every line of code you write costs money. It's not a product, right? So that also means that if you can write it more simple, it's always better. Right? So this is code that is already quite okay. This is TypeScript. This is from my own team. We write a lot of TypeScript these days. And this is already quite simple code. And I looked at it and I'm like, oh, I can make it simpler, right? I could make it into less code, meaning there's less situations to test, likely, because they're handled already somewhere else. So I'm always looking at, can I make the code more simple? Can I make it less code? Because, well, the easiest code to maintain is basically if you don't have it. Right? So all the code that you don't have, that you're using maybe from a framework, or don't write at all because you don't need it, saves time. And time is money, and time takes away the brain power that you have, right? So that's the thing, right? So I went into this thing that I realized only probably 2-3 years ago, that I was changing the way I write code. A lot, actually. And I went into writing single lines of code, right? Or single line functions. This is a function in my code. This is actually code I actually touched yesterday. And this is it. It's only one line. And I know there's complexity in there somewhere, but not in this line, which makes this code easier to test, easier to work with, right? And what I also thought myself is, every function I write, instead of writing all the code and then seeing what comes out at the end, I turn it around. And that might be a very tiny difference, but to me, it meant that I started thinking about how to write this code in a very different way. So all my functions, the first thing I do if I write a function, I type in the word return, because I want to figure out what should this thing return. And then, of course, I start writing a lot of tests, to which we'll talk later on. So, and we have to talk about naming things, right? Traditionally, and I've seen this a lot, especially in the Java community, we have the tendency to give our variables and our signatures the same name as the class that they are. This started when we didn't have IDEs, because we couldn't check. That means somewhere else in the code, if I wanted to see what the type of a thing was, I had to deduce it from the name of the variable. We don't have to do that anymore, right? We have really powerful IDEs. If I hover over a variable, I can see what its type is. So I don't have to put that in its name anymore, right? It's not like I'm going to name my order repository, because I know it's an order repository. Also, because my code is really compact, I can still see where the signature sits, right? So that means that it becomes a little bit better readable. So it now says orders by order item ID. And I even want to remove the ID from that function name, right? So I make it shorter. It's not like get order item by order ID, la 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 la. It's just short. And I tend to write shorter code the older I get. I think I don't have the space anymore to write long function names. Of course, you could also do it differently, right? If my clicker still works. This is also a very good example of how to name things. This is an abstract annotation config dispatcher servlet initializer, of which I have no idea what it does, by the way, but this is not what I would call this thing probably A. Well, the variable with this type, right? So anyway, so start doing things differently. And you can see it on my function names as well. They're really short. If I'm in a certain repository, like the order repository, I know that I'm getting orders. So I don't have to put that in a function name. I'm just going to say, well, get them by key, or get them by ID, or just get all of them, whatever, right? And the function is called all. So I started to doing really shorter names. And it actually, I think, so this is my journey, right? So it made my code, for me, much more readable. Also, if you think about security, all the code that you don't write is more secure code than the code you write, always. Because security is extremely, extremely hard. Right? I'm training my CISO in my company to recognize all of these codes, and he puts all sorts of tools in there, and it helps. But the best thing is, don't write code. If you don't have to write the code, it's more secure. And then we have to talk about architecture a little bit, right? So architecture is always hard. So here's the thing about architecture. And this is the wise programmer Charles Darwin. Oh, he has a beard, so he must be a programmer. And he says, well, I sort of adapted his quote. I said, it's not the stronger of the architectures that survive, nor the most complex ones. It's the one that is the most adaptable to change. What does that mean, adaptable to change? Well, if you talk to Neil, he would say an evolutionary architecture supports continual and incremental change. Right? So you can always change it in whatever direction you want to change it in. That's a good thing, right? And Fowler, in his short definition of microservice architectural style, he started going into the same direction. Well, he talks about business capabilities, right? It's all about the things that you might want to change over time, right? And I figured out when I was writing a book in 2003, which is in Dutch, so half of you can't read it anyway, it's still sold. I have no idea why, right? I think we're stepping away from UML, sort of, but people still buy this book. I have no idea why. And there's an architecture in that book. I'm going to show you that really, really briefly, because I'm sort of a bit low on time, but I started later, so it might catch up. And the architecture has a bit of a layered pattern. And I'm not saying to use this architecture, but it's an example of how I used my architectures over time. And they haven't changed, actually. So here's the domain with all the entities and the value objects and the enums and whatever you put in there. And there's repositories in there, and maybe a factory or a service or two. And then on top of that, we have use cases, which might be peculiar to you, but it works for us, right? So, and then, well, there's the resources. This is basically the architecture of how we do microservices these days. And then you have to go out to a database or other service or whatever, so we call them gateways. So this very simple architectural picture with how they work together, I had this in my book in 2003. I'm still using this. Not because it's the best architectural style you can have. It's a architectural style, an architectural style. It works for me, coincidentally. And the nice thing is, if I look at my code bases over the years, and I really, really hate the way I wrote code 10 years ago, but I couldn't have written it any differently because I didn't have the ideas and the knowledge that I have now, right? So this is a code base that I found recently on Bitbucket, which I never go to, but and it has this structure already. This is a C# code base from 2009, I think, and it had the packages already that I still have in my architecture. If I look at how I wrote my repositories in 2008 in C#, they looked like this. But it is a repository. Or when I wrote them in Java in 2015, they're also repositories. They have the same responsibilities. It's the same idea, different language, different paradigm. Also, I was trying to write some functional code in here. Most Java developers really didn't appreciate that at that point in time. They do now, though. And if I look at a repository these days in TypeScript, this is one that, well, I actually touched this one yesterday. It's still the same thing. It's still a repo. And we call it repo, it's shorter, right? But it has the same patterns. It follows the same things. It has the same responsibilities. And the architecture didn't really change. But it's still in different, I can still recognize old repos. Now, if we have a whole bunch of them, and this is a screenshot I took 2 days ago, these are half of our services that we currently have, they all have the same structure. That doesn't mean they're written all the same, because different people have written them, so they have different sort of handwriting in how they write code, but they follow the same patterns. That means they have sort of like the same architecture, which means I can go in every one of them and still recognize it, even 5 years later. So that, for us, kind of works, right? So let's pick it up. So developing software is hard, right? We all know that. And how hard it is best illustrated when looking at the JavaScript space. So I looked up React state management libraries at one point in time, and I figured out that there's a collection on this page of the 32 best React state management libraries. And the first question I had is, what do you mean 32? How many do you need? Well, 1, maybe 2, but that's it, right? And it's even worse, because these are the 32 best React libraries, which means there's probably a whole lot more. What's the point in this, right? And I was wondering, like, do we need all this stuff? And then I have to come up with Cynefin, right? Because this is why we do this stuff. You have to actually learn this model because it's really good. So the thing with this model is, I'm going to try and explain it in a single minute, which is hard enough already. It has 4 zones in it. Now, in the obvious and the complicated zones, there's either a best practice that you can just apply, or a set of good practices that you have to choose from. You do some analysis, you can do the work. It's pretty much plannable. But if you're on the left side in this diagram, in the complex or the chaotic zones, you're in trouble. Because there are no best practices, there are not even any good practices. They are emerging, which means probably somewhere out there in the world somebody has done this before, maybe not. So how do you know how to solve this stuff? And the problem is, we are mostly on the left side in this diagram. That means we are in the world of the unknown unknowns. That means we cannot just puzzle until we get there, because there are no best practices. There are no practices in this industry that work everywhere. At best, we have some good practices, but they only work within a certain context, right? So that means you have to figure out which ones do work for you. This one works usually, right? Coupling and cohesion, having high coupling, low cohesion instead of the other way around, that kind of works in everywhere you go, in all the code you write in our services, but also in our monoliths years ago. It sort of works, right? Or the Unix philosophy, right? Write programs that do one thing and do it well. Yes, do one thing. That is good, right? That is single responsibility principle. It's saying, okay, everything that you have, every module should have the responsibility over a single part of the functionality, right? And it should do just that. So with every line of code I write, I'm trying to figure out what is the only thing this thing needs to do. And if I add more stuff to it, it becomes more complex. And intuitively, it doesn't feel right, right? This is code from my team from probably half a year ago. They have a single repository, and they have like 5 gateways in there, which means there's 5 parts of data that they need to get and grab together. And I'm like, nah, this is sort of giving you a gut feeling of that you can probably design it better. This thing probably does too much. So you need to rethink that. And that is something that you learn over time to do that, right? So if you look at code like this is the code, but it's in the same class, and I'm like, I really don't like this. We should rewrite this stuff. This is not maintainable. I can't understand it, and the code got more complex eventually. I can't understand this anymore, right? So you have to get rid of it. And I started to get rid of more things in my life, like dependency injection. Here's some dependency injection, right? We do object create and whatever, blah, blah, blah. We create all this stuff. And the problem was, it always adds more stuff, unpredictable behavior to it. I do like DI for a lot of things, but I also like my code without DI. So I'm basically doing this now. I'm saying, okay, I have a constructor. It has a read-only variable, and it's a managed shop. That means if I don't pass anything into this function, so it has a default value, it's OK. If I want to pass something in, which I do, to be able to test it, I'm OK too. I just lost it. And then, this is a topic I can talk about for days probably, but the problem is I don't have days, right? And I need to do so much more. So if you don't mind, and the problem is I don't have my laptop here, otherwise I would be able to skip this without you seeing it, but I am going to skip it now, but please pay attention to monads. So, blah, 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 all monad stuff. Yeah, and I'm even trying to explain it in like 3 minutes, which you can't. Yep, right. Next big thing. Do you write unit tests for everything you do? Be honest. None of us write it for everything, right? I still have developers in teams that say, why do I need to write tests? Honestly, it's 2022, people, and people, you need to do this, right, basically. So the question is, when is a test a unit test? Now, Michael Fedders has a very nice, well, not definition, actually. He says, well, a test is not a unit test if it talks to a database, reaches across the network, or it touches a file system, opens files, closes it, adding stuff from somewhere, if you cannot run it at the same time as other tests. That is interesting, too, right? You have to be able to run them in parallel and in different orders, because, well, they do sometimes. And all the stuff you have to do to configure it, it shouldn't, right? The rest is probably a unit test. So why do you write unit tests? Well, basically, to test the code that I wrote, and to be able to make sure that when I put it through the pipeline, that it still works, or that it still compiles and that it has the right functions, et cetera, et cetera. But you can do much more with it, right? This is just unit testing. And it is cool because, well, it ups my percentage of code coverage on Sonar, right? So it's about 95.4. Cool, right? It's probably not my code, but anyway. So, and that is cool. But and the thing is, it gives you a lot of confidence. It allows you to say, hey, wait, I can actually change the code, and I run all the tests locally, and then later on in the pipeline again, and it still works. And that's great. So I can check it in. That means basically that I can check it in more times. I actually check in my code into the master, because we do trunk-based development, right? Probably like 20 times per day, right? Maybe more, maybe less, but that's about it. And that means also, I actually realized that I hardly debug my code anymore. I just write a test for it. And if it doesn't work, I write another test. And it gets a lot better. So I rarely use my debugger anymore. And if I debug, it's basically my test code that I'm debugging, which is kind of strange, right? And then you have to figure out, so what is it with this testing? Well, this is what one of my developers said recently. She said, well, I wrote all the code for this feature, and now the business has to test it. And I'm like, so when are they going to do this? And they said, well, when they have time. I said, is that going to be this week? She said, well, maybe. I said, well, maybe you should write the test so you can exclude already most of the things that the business should test, right? And she said, okay. And she got better. And she said, well, then I just wrote all the code, and now I need to write the tests. So she wrote the code first and then the test. And then she got better. And said, well, maybe you can split it up into smaller stuff and test the small stuff, right? And so she said, okay. She did that. She said, I refactored the code into several small functions, as she suggested, and they're much easier to test. Cool. Step up, right? And then she said, well, now I need to write the tests. I'm like, okay, that's still not good. So the question is, why do you do this in this way? This is okay because, well, in the long run, it helps, right? It helps you gain the confidence to change the code and make sure that it still runs in your pipeline. But you can do much better, right? Because testing is basically, or these testing techniques are becoming a design technique, like in TDD style, basically. And then Gerald Weinberg says, well, design is the progressive elimination of ambiguity. That is really cool, right? It means that if you have more tests, you can get rid of more of the ambiguity in your code, meaning it becomes simpler to write. So what do? Now, and Dave, who's in the room, he said, well, apply scientifically rational thinking. Start with assuming that you're wrong instead of that you're right. We always say, well, oh, here's my code. It should work, right? I have developers on my team who always say, it should work. And I'm like, probably not. And they're like, yeah, and then press the button. No, it doesn't. Happens all the time, right? But if you start from saying, wait, I assume that this code is wrong, write my tests to make sure that I can see that, and then improve on it, is a much better approach to do that, right? So if you think about simple code like this, right? So what do I do with this? I had to add some code to it, but this is simple stuff to test, right? But still, I would write a test. And the test would say, well, here's some scopes, and if you have scopes, if you don't scope, test the method, see if it works. Well, it probably works the first time because you don't do anything, right? Because if I don't have any scopes in there, it should not be allowed. Okay, good. Then I write the actual signature. So I'm adding scopes to the signature and saying, okay, we need to put in scopes, and the test still needs to succeed, right? Then I test it, and I say, well, you know what? It still works. And then I start writing all the tests. And what I usually do is I write them in order, that I write all the failures first, and eventually I usually have one or two cases that test the situation where it's actually doing what it needs to do. And it sort of builds up my test code. And I built my code along this. This is just a pattern that I learned to work in throughout the years, basically. It's running the test continuously. And then in the end, I write the right code, and then I run the test again, and they should work, and then I check it in. Immediately, by the way. I check it in all the time. And I would say this is much more an active way of doing your test, right? This is basically what TDD does. By the way, you have to remember that your test code is also code. A lot of people say, yeah, it doesn't matter what the test code looks like. It's just the test code. No, it's not. It's code that you need to maintain. Because every change you make to your actual code base, you're likely also have to look at your tests. And if you can't read your tests anymore, you're doomed anyway. So please make sure that you maintain your tests as well. And here's some other code examples that say, well, I just moved it into this. One more thing then, I think. This is the actual stack of one of my clients. They went bankrupt, by the way. True story. This is way too complex, right? And the number of people they had to work on this stuff was not enough. The problem is, and Dijkstra said this, I think in 1980, and he said, like, the programmer has to be able to think in terms of conceptual hierarchies that are much deeper than we ever needed to face before. This is very complex work. The problem is, there's always stuff you don't know. There's so much I don't know about this industry, about how to do stuff, that I also don't want to know. I'm not an expert on infrastructure. I'm not an expert on databases. I like writing code. But there's other people in my team who actually do this. And that I came to the realization that, well, basically, it's not a person writing the code. The smallest unit of writing code is a team, right? It's not an individual, because our industry has become way too complex to still do this as an individual. You have to work in teams almost all of the time. Sometimes the team can be one person, but it's usually a bit more. Because you are here, and you have no way to make this stuff plannable. That means, as Dave Snowden, the author of Cynefin, says, that you need to innovate. You need to experiment, right? And by the way, an experiment is a test done in order to learn something or to discover if something works or is true, right? You figure out stuff. You have to let these practices emerge all the time. And the best thing to do that is by learning. And we're back to learning, right? And I figured out, well, basically to write software, we need a whole bunch of people. So the fonts have disappeared, actually, from the slide because it's running elsewhere. But you need a whole bunch of people together to produce this software. I have people in my team who are excellent on Flutter. I have people in my team who are excellent on React. I have people who know about microservices, people who know about infrastructure, people who know about databases, people who know about Elastic, people who know about PHP, people who know about ERP. All these people together make the software work, right? So it's always the teams. And I figured out that every work item that you put in there, whether you do that in a backlog, in a sprint, or just put in work items, they're all different. And that means with every item that comes in, every thing that you do, it's a different setup of people that actually can do the work best on this bigger thing. So I started calling that actually micro teams. Everything has to be micro these days, right? So, and then you can solve the problem. So you pick the problem, you form a small team of 2 or 3 people who can solve the problem. You do the work, you check the code in, and you go on to the next thing. And that is basically how the teams I work with started working over the years. My current team actually does it. We don't have sprints. We don't have a backlog. We actually don't have estimation. All the stuff that you really want to get rid of, we've gotten rid of it. Because the only thing we do is stuff comes in, we look at it, and we say, OK, let's pick this up. And people pick it up. And they form different teams, like a team of a developer and infra guy, or 2 developers and a tester. The tester has to stand, of course, and or 2 developers. And you can see that because they have beards, right? And or this one. This is an architect and a developer, and the architect is praying for it to work, and the developer knows it doesn't work. So we started going into this micro-team thing, and they switched all the time. And it became a very dynamic context in learning, right? So the nice thing is, Martin, I'm not sure if you're in the room. You were here earlier. All right. And I was like, it doesn't matter if this technique works at scale. I'm not working at scale. And he says, well, it does work at scale, right? And you're not going to talk about this today, right? But so it was nice to see that it actually works at scale, too. And I still owe you, you owe me a cup of coffee anyway. So, so last thing, and I'm almost out of time, right? So this is an interesting question. This is my mom. And I'm taking her to dinner when I just got back from holidays. You can see that because my tan is a bit different, right? And we went to Italy. Now, my mom went to France for 25 years in a row to the same campsite with my dad, stood at the same space, did the same things, visited the same villages, and she truly enjoyed it. And now she's like, why did we never go to Italy? I showed her all the nice pictures of Italy, right? And she's like, oh, why did we never go to Italy? Because you always went to do the same thing. And that is not necessarily a bad thing. It's different. Right? So some people actually like to do the same thing because it gives them comfort, it gives them security, and that's good. 3/4 of our industry is probably like this. People who like writing the code as they did last week, and etc. And still, you can evolve. And then there's these other types like me, if you only need 1 or 2 in every team, that love the change. So we're going to change the code anytime we have the opportunity, right? And you need both, actually. So one is not better than the other. The question is, what if you want to actually change stuff? I actually tried this out once on a Saturday morning when my kid had a football match, and all the parents came in with their cars, and there were like these nice things, and I was like, oh, let's try it once. And I parked my car in the wrong way. And what happened is, the other parents started doing it too. So here's the answer to the question. If you want to change things, if you want to make a change, don't rely on your manager, on the other people in your team, although you need to work with them all the time, but don't rely on the others to ignite the change. If you want to change, it's only you that can ignite that change. Like somebody on my team said, yeah, this pipeline actually doesn't really work, and I need it to run automatically and it doesn't do now, and I'm sad. Like, so what are you going to do about it? Fix that, right? So make the pipeline to run every 15 minutes so we can do the work automatically instead that you have to push a button every day. And she said, yeah, but I don't know how to do that. I said, well, what do you do then? And the thing is, you ask for help, right? Which is hard for a lot of people, I guess, but it is the only thing you can do. You ignite the change and ask the rest of you to help, right? So never, ever be afraid of asking questions. I ask the dumbest questions all the time. That's basically my work, right? I say, yeah, but what is that? It's a database. Oh, what does it do, right? Stuff like that. Don't be afraid to ask the questions, because a lot of people in your team or at the table will be there and like, oh, he dares to ask that question. Why didn't I do that? I want to ask those questions too. Just ask them, right, people? Nobody's going to shoot you. Well, not here, but so ask the newcomer questions, right? And take really, really, really small steps in everything you do. That goes in your personal life probably as well, but it also goes in writing code. Make stuff small. And never, ever stop learning. We need to be lifelong learners in this industry. And it never ends, right? So I hope you took away something from this today. And this is the most important thing, I think, is never, ever forget to have fun. And if everything fails, you can always remove your node modules, right? So, by the way, one last remark. Take your mom out to dinner more often. Before you know it, she's not there anymore, right? She's still there, by the way, but she's made of iron, I guess. But so go off and have your mom often for dinner, right? So that's it for me for today. Thank you all for indulging me for about an hour. And I hope to see you again later.